it is now recording. Okay, so let's go into Brightspace first. Let's start there. Okay. All right, so we're on Brightspace now, and let's go into content. And if you look, so we've covered all of this, and then, you know, RCM, we covered this last week, I believe. And then we are here, IPTables, right? And then the Seed Labs firewall and software VPN. So this is all we have left in the semester. And then I'll do a lecture on this at some point, but there's no lab associated with this. So really, we just have this one lab and one more. Today, we're going to focus on this module here, IPTables. You can see it says Raspberry Pi. So we usually, you know, before the pandemic, we would usually do this part of the lab on the Raspberry Pi. Okay, so it's kind of, you know, too bad we don't have it. Unfortunately, we're going to have to simulate some of this on the VMs, which it can be done. But, you know, I decided that I just made all the materials available in case any of you wanted to do this on the Raspberry. Now, keep in mind, you know, I'm not saying that you're required to purchase a Raspberry Pi, but if you, by any chance, have one lying around, you know, you could do this if you're up to the challenge. It's not very difficult, honestly. So here I provided all the materials that you need. Okay, so I provided all the materials. If you, now again, I'm not saying that you need to purchase anything. If you wanted to do so, you can get a Raspberry for about $20, and then I'm sure the USB to network cable, you know, probably somewhere around $10. In any case, so these are the materials, right? So I'll go over, first, I guess, let's start with I have a few things. So there's the solutions. I've actually provided all the examples, so you can just kind of apply them here. And also the problems, of course, I've already created the problem set. And then the other two documents just have to do with configuring taking a Raspberry Pi and making it into a two-network interface router, basically. And the advantage of that is that, you know, whenever you want to do any kind of networking tool, you know, of whatever kind, you can just easily, you know, get this going, okay? And so it's very inexpensive, and it's actually extremely powerful. As you probably know, Raspberry Pi, it's a Linux, mini Linux operating system, and so all the commands work, and it's pretty consistent with Linux itself. All right, you can always, you know, I'm sure you know this, you can just SSH. You can connect a monitor if you have one lying around, but you can always just SSH into the Raspberry. Anyway, so I thought I would kind of motivate this today, right? So we're going to start with the problems, then we're going to work through some of the solutions, you know, how they work, and then basically I'll talk about the Raspberry as well, and how that can be, the configuration would be done. And then after that, just show examples of, okay, you know, here's the scenario that we want to address, and then here's the rule in IPTables. And remember, this is all for firewalls. I already talked about the chains, input, forward, and output. So remember, those are really important. You should always, in your notebook, you know, write down your network and then kind of think about, okay, what chain is this possibly going to be affecting? All right, so let's talk a little bit first about the problems. So here, as you can see, I've got 10 problems on these. So let's take a look at the type of problems that you might have. So for instance, number one, you can see block Icmp packets going into the router. Now, what that says is that they're not going through the router. They're not initiating from the router and going out. They are literally going into the router. What does that mean? What is the input chain for this one? It is input. Input is the chain. Number two, block SSH request to a server on the internet. So I have a server on the internet that has SSH on it. So you can try to, I'm not going to give you the login and password, but you can try to SSH into it. And of course, so when you do that, it shows, it shows, it'll show login. Now, now it's time to log in and type your login and password. However, when you add a rule on the IP tables, then it won't even show that. It'll give you an error, okay? So in this case, you can, if you had a two network interface device, like a router and a Raspberry, then, you could put in a rule in the forward chain that prevents this from happening. So anything on the inside network cannot SSH. So remember, with all these problems, you have to show first that it works, then you add the rule, and then you show that it doesn't work, right? So that's what I want you to do, okay? So again, in the second scenario, problem number 2, block SSH requests to a server out on the internet. This one you could do either forward or output, right? So if it's, because you could also initiate the SSH from your own machine going out. So that would be the output chain. Port forwarding is a more complicated one. So I'll have to talk quite extensively about that one. But basically the idea is from B, access SSH service on A. I kept it pretty generic. And the reason for that is I have to explain it quite a bit. But I gave you the scenario. So I'll do, as part of the lecture, formally discuss this one. But I just want to stress the idea is the best example, the most intuitive example of this is your home, right? So you have your home, and on the external ISP side, you have an IP. And then on the internal, you have a server. Let's say an FTP server, an SSH server. You have your homework there. You want to reach it from the outside somehow. So what you do is you from the outside, you SSH into the IP of your external house, right? Your external IP of your house, and then you need to specify a port number. When you hit that port number on the outside, you need to have a specific set of rules in IPTables that would allow you through that router and into your house, because it's going to forward the packets that hit on the outside interface at port, let's say 1000, to an internal IP and a port number, where, your FTP server, etc. So this one I will talk about, but it's a pretty interesting one. So we'll take a look at it. Number 4, block HTTP traffic going from A to the outside server as well, the one that I provided. But this time around, you will block it by IP address, okay? So your rule needs to do the drop by IP address, okay? Whereas in number 2, you're blocking by service, okay? So basically by port number. Okay, guys? Does this make sense so far? Yeah? All right. So we're gonna, as I said, I'll provide examples of these. Some examples are already in the notes, actually. So you can just take a look at them. So I did number 4. Number 5, implement a rule that blocks telnet and logs that block to a text file. So in this one, I want you to figure out how to, okay, not only am I gonna block, port 23, but I need to log it. Okay, so, in some kind of a text file. So you have to do that one. Number 6, block a DDoS attack on the router from the inside the network. So important for this rule. Yeah, so this is if this doesn't apply for us because we're not at school. So my concern is always running. They don't like it when we run things like this in the school's network, and the Raspberries. We would connect them actually to the network in the school. So that's not possible, but that's not an issue. You're at home, Now, if you're doing this at a cafe or something, just be mindful, be careful with that. So again, in this rule, you're going to block a DDoS attack on your VM or your device. So you need to think of the rule for that. Number 7, you're going to drop traffic by MAC address for a specific PC, right? So this rule is just about MAC address. Then number 8, this one is similar to one of the examples we did, I think, for, what was it? We did something with subnets, I can't remember. But add and test a rule to block a specific subnet. So as you guys know, subnetting is very useful because it allows you to just create rules that, you know, deal with those subnets in specific ways. Okay. Then number 9, add a rule to block all SSH traffic going through the router or through the device, let's say here. Then devise a scheme to bypass this rule. Okay, so I'll show you guys later on how to do bypassing firewalls. So it's pretty straightforward. You just create an SSH tunnel and then you kind of redirect all your traffic through that tunnel. So therefore, you need a computer on the outside though, and a computer on the inside so that the tunnel just goes through your device. And then, okay, this one, implement an IDS service on the PI and test it. This one you can skip. Implement an IDS service. I don't even know why I put that in there. All right, so we can skip that one. But these are the rules. As you can see, they're very, very basic and straightforward. They're, you know, the only one that might be a little bit challenging is the port forwarding, okay? But all the other ones are pretty easy and straightforward. I may change this number 10 to something else. Are there any questions, guys, at this time?
I have a question.
Your homework. Problem 1, I want you to understand, right? It's not, I don't want you to say, well, you know, the PDF, should I do problem 1? This is what you need to do related to IP tables. Does that make sense?
I have a question.
Yes, go ahead, please.
I'd like to clarify. At the beginning, did you say this was an optional lab or for challenge?
It's not an optional lab. You have to do it on the VM at least. What I did say that was optional is we usually, before the pandemic, we would do this lab on the Raspberry that we have. We have like physical Raspberries at school, but so I know there's some of you that, you know, like a challenge. So if you have a Raspberry lying around, I'll show in a minute some documents of how you can convert it into a router. You can even buy the, you know, if you want the equipment. But if you don't want to do that, it's perfectly fine just to use your virtual machines. You can also do it there. Make sense? Does that answer your question, Angel?
Yes.
Okay, great. So of course I will provide, so that, you know, I'm just motivating today's lecture with these problems. This is what you must do. And then I'll provide some examples in the rest of the lecture today, okay, of how to do these things. All right, any other questions? So this, again, I will repeat this in this module called IPTables Raspberry. I'm going to create the first link of your homework, and it's basically to do these problems, okay? You just have to do these. They're all very similar. I mean, they're just little, if you notice, they're just like, in one case, you're going to block by IP, and another case, you're going to block by port number or by protocol or by MAC, you know, so it's going to be pretty straightforward. All right.
I actually have one more question.
Go ahead.
So are we prioritizing this lab before the firewalls one?
This is the firewalls one. You mean before the seed labs .pdf is what you mean.
That's because you have a seed firewalls.
Yeah.
That's
So again, remember the PDF is only a source for reference, right? I always change the problems, and I'll either write on the link what I want you to do, or I'll give you a document like this. So I'm saying you're going to have at least 4 things related to the homework. This is the first one, these problems. Everything related to IP tables, you just have to do this. Read the PDF. Don't do anything in the PDF. Do these 10 related to IP tables. Does that make more sense now?
Yes.
Okay, great. Any other questions, guys? Okay, so I'm getting a question about some of you, if you don't have a Raspberry, how do you set up the network? So if you think about it, actually, so the trick about this is that most of these are either input or output chain related. If you read it carefully, there's only a couple of them that are forward chain. Okay, and the ones that are forward chain, we can also do with the VM. There's a workaround I'll show you guys today of how we can sort of simulate a two network interface router on a VM. Okay, so we'll cover that as well. But basically, that's what's important. So let's take one example, I guess. Let's think about block S, and this is the reason why I actually set up my own server as kind of the target, because that way it gives you an outside network. In this case, I have a server in the cloud. Now you're not going to attack it. Again, please don't do that. But you can SSH into it, you can ping it and things like that. So there is this idea of a couple of networks, right? Your VM plus I have this server on the internet. So let's think a little bit about just one rule. And of course, you know, the lecture is really going through all these things. So let's think block SSH requests to that server, something on the internet from the inside network. So in this case, it can be from the machine itself because we don't have a Raspberry. So it would be something like this. I'm going to go to the whiteboard. So you should be seeing the whiteboard. And if we take a look, basically that's the internet, that's the web. I have a server. I forget what it was called. Let's say 192.192.1.17, something like that. So this is a web, but it's got several services enabled actually. Right now, do not attack it, but you can use it for these services to see the web or the SSH. Then you're at home, you're at your own home, I assume. And so that's your router at home. You're not going to do anything with that router. And then inside, I assume you have your CVM. If we had the Raspberry, we would have the additional option of having a switch there, right? So that's separate network. We don't have that unless you want to build it. As I said, in a second, we'll take a look at that. But you can still do this because the only difference that I want you to understand, and I'll kind of draw the contrast. If this is the Pi, same thing, but you have the option of a switch. So you have an additional network in there, right? And so in the Raspberry, you can add a rule, right? So hopefully you guys understand this. If I do, for instance, I can SSH from that device, or I can SSH from that device, right? One would indicate that you are SSHing from another network on the other side. So this would assume this is the Pi, so it's got two network interfaces. It's acting as a router, right? So if you want to block this SSH, okay, guys, so if you want to block this SSH going through, what do you use? You use the forward chain. Does that make sense? However, if you don't have the Raspberry and if you only use the VM, if the SSH service is initializing from seed, which chain do you use for the rule? Output, correct? Output. That's the only difference. The rule will be the same. It'll work just the same. You just have to think in terms of which chain you're supposed to use. Which one will be the correct one? Is this clear for you guys? Okay, great. All right, so yeah, so that's the idea. So again, I encourage you, if you have, we'll in a second we'll talk about the Raspberry. I think you probably are more intimidated about it than you should. It's pretty straightforward. So if you have one lying around, give it a try. Also, $30, would get you in a Raspberry. It's a useful thing to have. But yeah, that's otherwise you don't have to buy it. Just use the VM. We'll talk about that as well. All right. So that's the scenario that I wanted to give you. So hopefully that was clear. All right. So now if there's no other questions, let's go over back to Brightspace. Okay. So I'm going to go switch over to Brightspace. All right, here we go. So this is Brightspace. All right, we are in the module, this module, the table of contents. All right, and this is the module, Raspberry Pi. So you can take a look now. I've actually provided the rules, so we'll take a look at those last. We've looked at this one, that's the problems, and then these two documents have to do with configuring the Raspberry. So basically making it into a router. So what you need here is, this is titled, so you should be seeing this document, IPTables Firewall with Raspberry Pi. The objective of this document is for configuring the Raspberry Pi 3B Plus to work as a wired router, okay? So remember, that's a good note. It's not Wi-Fi, right? It's not Wi-Fi. Although that's actually something else that you guys have, right? So in a sense, your computers do have Wi-Fi as well. And that's a separate network. So when you're in your home, but in your home, yeah, I was thinking at school where we have two networks. In your home, you only have the Wi-Fi network. Okay, that's fine. But anyway, just keep in mind that most of the discussion is about wired, so wired router. And so this document talks about converting a Pi to a wired router and, of course, IPTables, using it on it so that it can be used to implement some rules. This provides some of the, I'm not going to read through the document, obviously. So this provides some of the requirements, talks about the hardware and the things that it comes with. Now, we don't need Bluetooth or anything like that. A switch. Yeah, so the thing is, at school we have the taps, and we could just use those as switches, but hopefully you have a little switch at home. If you have one of those old Linksys routers, for instance, you can always just use the back of that as a little switch. And then definitely you do need the USB to Ethernet, right? Because the Raspberries only come with one Ethernet adapter. So, but that's actually part of the configuration, is just to connect to one of the USBs, and then you need the adapter. All right, and then this even provides the one that we have used in the classroom. All right, and then the software requirements. So then you'll install these if they're not available in your OS. Of course, as you know, the Raspberry uses Raspbian, right, which is the it's like a mini Linux. It's really nice. And then the year and version is there. Okay, and then after that, so that's the specs on the requirements. And then after that, as you can see, it basically just has the configuration. So everything, the commands that you would have to run, okay, the configuration of the networks, right, because you're going to have a couple of networks there. So so you just do these configuring DHCP so that it serves the IPs, but basically you just follow these commands. We've tested this several times and it should be pretty straightforward. Okay, so now you also need, now if you notice, these where it says sudo IPTables, these also these look like IPTable rules, but these are specific to making the router work. So as it turns out, by default, IPTables does not like to make the device into a router, so you'd have to configure these as well. All right, you can see the setup there. Basically, once we have the Raspberry, we have two network interfaces, one on the internet and one, the inside one, and then you can connect all your computers. You can see there, this is because at school, we would connect this basically to the school's network, so that would give us a 205 IP, and then the computers that we connect here via DHCP would get their own IPs as well. And that's it. As you can see, it's not even a very long document. You can just go through that and it should be, as I said, this is not required, but I thought it'd be fun for some of you to at least read through. All right, this document is just specific to the Raspberries and how to make them into a router. The second document that I provided is also kind of in the same light. I think I clicked on this one. So we've read this one. And so if we click on this one, it's pretty much the same document, right? So you can just read through it. I just happen to have 2 copies of it. So read through it. And then here, what's important about this document is, if you notice, the other one just ended in the diagram. Here, actually, it provides now some insight into testing it with IP table rules. So for instance, one of the rules that I've given you in the assignment is to block Icmp packets going to the gateway, let's say, or something like that. So here's the rule, basically. Okay, that's the rule, and that's what I'll talk about today during the lecture. I'll do a few more of these, but this example is provided. Then, of course, how to test it. So, you can use ping, of course. That's a good medium. Remember, in every problem, show me, okay, here it is, it works. And then we added the rule, and guess what? Now it doesn't. Right, so that's kind of how it works. All right. This also shows some additional functionality, like deleting rules, okay. And that shows you that you can ping again, right? So read through this, please. Now here's another one, SSH. Again, you SSH, like this is the example I gave in my problem, right? You're gonna connect to this server, set up for you guys to test. And then, of course, that works. But then you add a rule. The only difference is, notice this one is what's important that I want you to understand is that this is in the forward chain, okay? Now, this is a concept you need to understand, that forward is only, I've already defined this in a previous lecture and video, forward only applies when a packet goes from one network interface in the device to another one, okay? So where, such as router. However, it could go on the output chain if the SSH initializes from the device itself, okay? So it doesn't, so you would just change this from forward to output, for instance. But you're gonna test this by, initially notice the difference. It's subtle, but it's there. I want you to pay attention. Here you do SSH so-and-so, right? And it gives you enter the password. So that means, what does that mean? It means that you completed the connection to the device. On the other end, over here, you do the SSH and guess what? There's no enter the password. That means the firewall itself has blocked, okay? So keep that in mind, please. All right, the port forwarding, I will discuss this in more detail because this is a much more complex one, but you can see an example. It's already provided here in the handout. Okay, you can test it with PuTTY. And I believe, yeah, and that's, so this document is just a quick, it's not about, it's not the solutions to the 10 problems. It's really just, basically to give you a little bit of more insight into, after configuring the device, inserting the rules, okay? But I will talk a little bit more specifically about what all these commands mean in when we type IP tables, okay? Any question about this document, guys? Right, doesn't sound like you have any questions about it, so let's go to Brightspace itself. Oh, we're there. So then let's go to the link, is what I meant. All right, the last document is, I've actually provided some more examples that you can take a look of these rules, okay? So definitely my suggestion is read through all of these, okay? Read through all of them very specifically, okay? All right. So that summarizes the documents on the IP tables and this. So the homework again is basically to complete these 9 problems. I'll think of a 10th one there. I still can't remember why I have this. I don't see the relation. Yeah, anyway. So I'll come up with a 10th one and I'll update this document, but you can certainly start working on all of these. Remember, for a lot of these, you don't actually need the forward chain. That's actually the best advice I can give you. You can do most of these with the input and the output chains. Okay? Questions about your homework before we start the discussion of the lecture? All right, so I'm assuming it's clear. This one here is your homework. All right, so let's now then do one more thing. Now I'm going to switch over to the virtual machine. So I want to show you something. So let me start. All right, so I need to share the VM. All right, so now you guys should be seeing the Ubuntu. I think this is the seed VM that I just started. Yeah, it's the seed VM that I just started. Okay, and if you look carefully, I'm going to go to the terminal. All right, and in the terminal, I am going to do ifconfig. And if you look carefully here, I actually have 2 network interfaces, right? I have this one, which is ENS33. You can see that the address is 192.168.18, right? You see that there. And then I have another interface that I set up called ENS38. Do you see that one here? And this one has the network ID of 192.168.93. So basically, I have also configured the VM to have 2 network adapters, right? And to set that up, obviously I've already done it, but you can just take a look in here, and we go to preferences. Can you see this window that just popped up? Or do I have to share that?
Yeah, we see it.
You see it? Okay. All right, so this window here that says preferences, wait, hold on, it's not this one, sorry. So, which one is it? I think it's, yeah, settings, sorry. It's in VM and settings. So if you click on VM and settings, now you see this window, it says virtual machine settings. And if you look, you got memory, processors, hard disk, CD, DVD. Notice that I've created 2 network adapters, okay? 2 network adapters. So for instance, I have one connected to the NAT network, right? So that's ENS33. You can see all you do is configure this to NAT. And then you have a second network adapter. And this one, just to make it very easy, I just connected it to host only. So host only is a private network shared with the host. The advantage of this is that it basically is it's another network that's already set up. So it's an idea like you have an computer with 2 interfaces, 2 network interfaces. And that's what gives you this separation that you have 192.168.18 versus 192.168.93. Okay, so you have both of these networks basically now. So in a sense, if I think about is 80, 18 and 93. We go back to the whiteboard. So here in the whiteboard, 18 and 93. So the idea is that, you know, seed, you know, is now .18, .93. And then I forget, you know, 0 and 0. And this is 192, 168. And this is 192, 168. So basically 2 networks, okay? So you can play with this also to forward. You know, you can try to forward things between these 2 networks in your seed VM, okay? So the same idea, so that you can try to play with that forward chain if you'd like to, okay? If you'd like to, if you find it that you want to do it. Okay, now the other thing that I'll mention is that I think this is usually VMnet 1, I believe. We'll check, but I think that's VMnet 1, and then this is host only. You can actually configure these. All you need to do is you need to make sure that you have a computer where you have administrator privileges. So I'm assuming all of you are running your own, you know, Windows laptops, and you got the VMware. You're going to need VM Workstation for this. I'm assuming all of you have VM Workstation from the school. You can get it for free. You get a license. And so you can take, and you can check my website, the calendar website. The links are there for that if you haven't done so already. So if we go back to the VM, you can configure this network just by going to edit. So hopefully you're seeing this edit here, and then you click on Virtual Network Editor. And you see this screen. Do you guys see this screen? Virtual Network Editor.
No.
Nope. Okay. How about now?
Yeah.
Okay. So this one, remember, to get to this one, you have to go to VMware Workstation, Edit, and then click on Virtual Network Editor. Okay. And then you can see here, you have a way of specifying these networks. So I was wrong. It's actually VMnet 8. So you can create your own VM nets. You'll have to play with this a little bit. You can create a VMnet 7, 6, something like that, with different networks, okay? And that just allows you, whenever you create these adapters, these NATs, or these network adapters that you saw me, where we have 2 for seed, you can connect them to these networks, okay? So you can play around with that if you want to try to recreate you know, the seed VM as more of a router. Now, keep in mind, host only already provides a separate network here, 192.168.93 versus 192.168.1. So you can, even before you start playing with this, you can just try these 2 for a lot of your rules, okay? Does this make sense, guys? You can do this in lots of ways. The only thing is, you don't have to. Like I said, you could just use the input and output chains. But if you want to explore more the forward chain, remember the IP tables. So the key assumption here is this, right? That, so hopefully you understand. The key assumption is, for the forward chain to work, you have to have a device with 2 interfaces. So if you're using seed, right, and you want to use the forward chain, you kind of have to simulate this idea of 2 networks, right? So if you want to do that. However, most of the problems do not require this. And so it's okay if you just have this and then just use, you know, something on the internet. That's perfectly fine. What I just explained with the Raspberry, or what I just explained with VMware, are basically only if you want to simulate a 2-network interface environment. Make sense? you know, given the, you know, that we don't have the hardware and, you know, all that stuff, I'm relaxing the rules this time around. So you can basically just use input chain. So this is the key thing. You know, in IP tables, you use input and output, or if you really want to get the full experience with forward chain, you have these two options, either the Raspberry or configure what I just showed with the network editor, okay? I'll accept either one. Any other questions, guys? Is this clear for everyone? It's interesting because the rules are almost exactly the same regardless of which setup you have. The only thing that changes is really the, you know, do you put forward, input, or output in your rule? And it depends on, as I said, on what's happening. Okay? All right, so I'm not hearing any other questions, so I assume that's clear for everyone. All right, so let's go then. Let's go back. All right, so I'm going to go back to the VMware. So like I was saying then here, you can follow these. And this requires administrator privileges, but you can create other networks if you want, tie them to the interface that I just showed. Otherwise, just use these two that are provided. They work by default. All right, so I'm going to cancel this one. And let's go back to the VM. All right, so you can see then, you know, in conclusion, you have ENS, as I said, ENS 33 here, configure with a separate network ID 192.168.18, or you have this one 192.168.93, right? And that just happened because, as I said, I went into VM settings, right? And settings, right? You're seeing it, I assume, and then you can see there's two network adapters in there, that one and that one. Okay? So this is all for the setup of this lab. Now let's go ahead and just focus on the rules. Okay, so now we're going to move on from thinking about the setup and just thinking about the types of rules that we want to have available. Let me see where I am. Let's just go to Brightspace for a sec. All right, so that wraps up for the first link I'll post for the homework, right? As you can see, in summary, in this module, I will add a link and it'll just relate to IP tables. And the problems that I want you to work on are these basic, okay? Now, the next thing I will do now is basically just go over a lot of these IP table examples, just kind of, you know, illustrate how they work and hopefully get a better understanding of, you know, of what we can do of the syntax basically. So let's switch over then to the whiteboard. Okay, you should be seeing the whiteboard. And now let's talk about how to, you know, IP table rules. All right, so IP table rules. Okay, so that's what we're going to do now. So if you remember, last week we talked about chains and we talked about some of the commands. We talked about some of the commands, and I think we started with just a simple command. We said, okay, block an outgoing service such as SSH from a machine, right? And so the command was for that IP tables, and then we said -L, right? And we said, you know, forward, for instance. Remember, forward is for a router. And then we would say -n line numbers. Okay, and what this would give us is it would give us basically the table and all the rules that are in there, and the rules would have a number on them, a number. Now, if you want to insert a rule and you know the place, let's say you want to put it in the second position, so just right after the first rule in that chain, then you can type IPTables -I forward to, which is the position. So this is the position where you're going to put things, and then now comes the rule. So you say, well, I want protocol TCP and basically -- destination port 22, and then what do? -J drop. Right? So I think this is the rule that we wrote last week, and that's it, right? So this just, this allows us to view. So this just, view the table. And then the second one allows you to insert the rule. So if you think about it, this just says where. That's the where you put the chain, which is extremely important. And then this one is the rule itself. You see that. And the last part of it is the action to take, which is there's 3 actions: allow, drop, and reject. And the reject is really just the same as drop, but it tries to send back some ping, an Icmp with a justification of why something was not allowed through. Okay, so for the most part, you will just need drop and or accept, right? Or accept. And that's it. And then remember, this is simpler than IDSs because IDSs, remember, they're after the fact, so they don't actually slow down the network. Remember that firewalls are in the pipeline, right? So a firewall, you got your traffic going there, it'll stop a packet, right? And so it's got to be very fast. And to be very fast, basically, it needs to, it can only look at certain things. So if you look at it, what's it looking at? It's looking at, the TCP header, if it's available, and it's looking at possibly the IP header, and that's it. Okay, and Ethernet header if we're going to look at MAC address or something like that. But it's not really looking at much else, right? Much else. All right, and that's it. That's, that's one rule. We can, block SSH service. Now notice this parameter is important, right? It says DEST port, so destination port. It's going to port 22. So when you think about the packet, remember the packet will have, that's why we did the sniffing lab, right? So that you guys know, okay, it's got, destination port and the source port. But in this case, we're looking at destination port. So it's leaving the computer and it's going in the direction of another server. All right. All right, so let's do another one. So that's what I'm going to do the rest of the class today. Today, yeah, on Thursday. Then we're going to do, I'll leave it open for you guys to work in the lab, and then next week we'll probably do the firewall evasion and the proxy firewall. Those are pretty easy labs to do, and then that'll just leave the VPN and LKM the following weekend, and then we'll be done. All right, so let's do another one. These are really fun. So, and actually, what I'm doing is they're very similar to the problems I gave you. So, as you'll probably see. So let's think about another one. This one is, let's call it block an incoming port. Let's say, yeah. Okay. So for instance, here, what do we want to do? The objective might be that we want to block all service requests. We want to block all service requests on port 23. So telnet again. So telnet. Okay. So then how do you do this one again? So let's switch colors here. So the plan then is, you'd go to the terminal and you do IPTables. And then again, list. Now, in this case, input, right? Because remember, input just means that the connection is, so if this is seed, right, and this is connected to the web, the connection is going there. Now, of course, you can be in your home network. You probably need a second computer, your physical computer. If you have PuTTY, you can use PuTTY, probably. Just change the port to 23. That should work as well. All right, so IPTables -L input -N, and then -- line number. Right? And that will list out all the rules that you have in your input chain. And then now you want to insert a new rule. So you're going to do IPTables . So you can do IPTables . -I input, and then you want to insert it in position 2. What are you going to do here? -P TCP, it's telnet, -- destination port 23, and then you can say -J drop. It's the same thing. So any packets going into the device itself on port 23 to port 23 will be dropped. And that's it. Any questions? Okay, I'm not hearing any questions. All right, let's try another one. All right, so this one, let's call it block port 23, but for only one IP address. Okay, so block port 23 for only one IP address. All right, so in this case, again, you would list, right? I'm not going to repeat that, but you would list. And now you can do IPTables -I. Again, in this case, let's think of the network. So block port for only one IP address. So how do you test this one? Let's say you have a switch at your home. You have 2 computers. This can also be the seed VM and another seed VM. This can also be the seed VM and a Windows VM. As long as they're on the same network. Ping first, always. I would recommend always ping first. Make sure you have connectivity. Then after that, what do you do? So here in this case, this is 192. Let's say this one is just to make it. Yeah, 192, I guess. 192.168.1.7, and then this one will be 192.168.1.9. Okay, So then this computer is going to telnet. So this computer would telnet in there, right? Telnet. So port 23, obviously, I shouldn't have to say this, but of course, port 23 needs to be open there. Test it first that telnet works. Okay. Then what's the goal? Block port 23 for only one IP. So in this case, we want to block this one, 7, right? So then maybe if you have another computer, you have another one in the network. This one should connect, but this one should not. You need to block that one. So this one needs to telnet. This one cannot telnet. So it's got to be by IP, right? So we got to figure out then how to write our rule. So then we're going to say IP table -I input. Where do you write the rules? Here, right? So this is the firewall because it's going there. So the rule is written there. It goes on the input chain because the service ends on 192.168.1.9. Where do we insert it? You know, let's say position 2. And this is a telnet packet, so -P, which is protocol, TCP, and then we need to say the source IP. Remember that this packet, right, you know, it's got a destination, which is going to be 19, and it's got a source, which is going to be 17, right? We've looked at this extensively with the sniffing lab, so that should be pretty clear. And so then we're going to say, I'm going to write, continue down here. I'm going to say -S for source. And then you can say 192.168.1.7. Okay? Pretty important there. And then, you know, also, because you want to limit it only to destination port 23. Okay, destination port 23, because it's telnet. And then -J drop. All right, -J drop just, you know, it signifies that that's the action you're going to take. Any question on this one, guys? No questions? All right, let's move on to the next one. Now for this one, I'm just going to give you a generic approach. So, you know, I don't want to give all the solutions, but let's think about, you know, drop traffic. So drop traffic from a given MAC address. Okay, so that's a given MAC address there. So in this case, then the generic approach to this one would be IPTables. Now where? Now again, you know, when you say -I, is it input, is it output, is it forward? Well, it depends on the setup. So in this case, probably want something pretty similar to the previous problem. This is 1.17, this is 1.16, right? They're both in the same network. This one is making a connection to that one. But this time around, you're not going to block it by IP. You want to block it by MAC address, right? So you're gonna try then to do something like this. You know, it is ending up at this destination, so it's still the input chain. Okay, input chain position. Let's say 3. You know, it doesn't. It's up to you where you put it. It could be 1. I don't. You know, if you want to do that, it's up to you. And then we can say, now here comes, you have to think about MAC address, so -M, which is MAC, and then MAC source, and then, you know, the MAC address. So those, I'm just going to make up a number here, 000F. You can get the MAC address in the ARP table, correct? So usually if you just do like ARP, I can write it in here. So if you're on the terminal, you can do ARP. I think it's -A or -H something. You can try that. It'll list out the IP and its corresponding MAC address. All right, and then some EA 1 04 08, something like that. There's the MAC address, and then again -J drop. And that's it, right? So you add this rule, and then you see if it works. Any questions on this example? All right, sounds like you're all getting the basic idea. All right, good. So let's look at another one. So I'll just do a few more. And then, I'll assume that you guys can just take over the rest. So ICMP, right? So I think there's a question in there about ICMP for ping. So let's see what the question could be. Block ICMP ping requests. Okay, so block ICMP ping request. So you saw extensively in the sniffing and spoofing labs also that we could do the echo request, echo reply, and that was the type of ICMP packet. You could take a look at that. So the same idea here, right? You want to block or drop ping packets to your device. So again, we have to think of the network scenario. The simplest one is just to have that. So then again, once again, 116, 117, but now you're pinging. So you're pinging that machine, right? You're not pinging through it, you're pinging it. And so obviously that would be the input chain. If this machine was a router that connects to another switch and the ping was actually destined for that, then that would be forward, right? So for those of you that want to do the Raspberry solution or something like that. All right, so then you can just easily think about this one. You see the pattern by now. And for echo requests, we can try IPTables -I input again. It could also be output if, remember, when is output the case? When the ping initiates from here out, but you want to block it right there, right? So then you do output. So, all right. Now I've worded some of those problems, hopefully, to kind of get you sometimes to think in terms of input and output or forward, but we'll see how it goes. All right, so IPTables then -I input, again, position 2, somewhere like that. Protocol. Now this one, remember, it's a ping packet, so it's not going to be TCP. It's an ICMP protocol. Then you can specify --ICMP type. Okay, and then you can say echo request. Or echo reply. You have to, there might be a subtle difference, right? So you have to kind of think about that, and then -J drop. Okay, so here's another rule for us to implement. Any questions on this one? Nope. All right. Sounds like it's pretty easy. All right, so now we've talked about ping. So let's do another one. This one, I want to intentionally make it I want to make it intentionally a little bit more complicated. So let's imagine that you have, for instance, the Raspberry, right? So we have the Pi. It's got two network interfaces. This is connected to a switch. And then in this switch, this is the network 192.168.9.0. That's that network. And then here, this is connected to the web, the internet. So this one is 205.215.17.0, right? Remember, they would have specific addresses here, like .9.1, let's say, and .17.1. And then here, or something else probably. And then this one here would be, let's say, 192.168.9.8. So they're both on the same network here, okay? This is the internet, this is the web, and then the cloud, and then I have a server, let's say 184.168.17.2 or something. And this is a, yeah, and this one hosts either SSH or HTTP, web, that kind of thing. So in this case now, with that scenario, what do you want to do? You want to 198 once. So in this case, we want to block an outgoing IP address. So we want to block an outgoing communication to an IP address from a machine in the inside network here. So to do that, but we only control the firewall here, right? So we control this firewall here. We have to implement the rule here. But for a communication that is coming from here, so this, whatever it is, SSH, actually all communications, right, would go through here, go through the cloud, all the way over there. We want to block for all services, SSH, web, whatever it is, we want to block for all. So in that case, this definitely needs to be the forward chain. Okay, this would not work if you use input or output, right? It's gotta be forward. So in that case, because it starts here and the communication will go through. So now, how do we write the rule? Let's go ahead and write the rule. So it would be, it's pretty much the same as all the other ones. What changes is the chain. So I'm going to say IPTables, dash, again, you could say, remember L. For this one, you want to take a look at forward because you want to take a look at what other rules are in there. Remember that chains are sequential. So if you put your rule at the very end, remember there might be some rules before it that kind of supersede it. Okay, so you want to be careful about that. So you do dash L forward, dash N, dash dash line numbers. Okay, like that. And then now we can add the rule. So I'm going to say IPTables dash I. Remember, it needs to go in the forward chain. So forward, and then, position 1 or 2, whatever you want. And then now, key thing here, we want to block by this IP address. Therefore, a packet that starts from here, will have a, the packet will be going, right? That's the packet. It's going to 184.168.17.2. Therefore, that needs to be dash D, the destination IP. Okay, and so then you can hard code that as 184.168.17.2, and then dash J drop. Does this make sense? Any questions on this one? All right, doesn't sound like there's any questions, so I'm assuming it's all pretty easy, I think. The rules are, you probably start to see the pattern. The rules are really the same, and it's only the this that changes, right, depending on where you are. And so all that work of configuring the Raspberry just so that we can change that, but you know, it's important. Okay, so let me go back to the whiteboard here. All right, so we're back here. All right, so that's a couple of examples. Let's see, what else do we have? Oh, something else that you might want to do. Sometimes, you know, this, it's very common. Well, here's the thing. When you insert rules into, and don't forget about this, this is actually pretty important. When you insert rules into IP tables, I believe they are flushed when you turn off the machine unless you save them in a specific file. However, you know, you might insert, so this is something that funny story that students have done in the past, right? I used to do this lab with some WRT routers, and one time students, you know, the WRT router has a file, and they put a rule in the file, right? And when they put that rule in the file, every time you restarted the WRT, it would load these rules. And I believe the rule that they wrote was something like IPTables insert into input, deny all, or something like that, or deny, you know, by, you know, deny, I don't remember exactly, but they just denied everything. So we couldn't web, we couldn't SSH, we couldn't telnet into the machine because this was actually hard-coded in there. That's called bricking the router. So I don't think that you can brick your VMs, but just be mindful of that, right? That think about the rules that you're inserting, especially those, you know, those like deny all kind of things. And then when you've added a rule, it's probably a good idea once you've tested it and you know that it works really well and everything like that, just to delete it. Okay, just delete the rule. So let's go ahead and do that. So we're going to. It's pretty easy. If you want to delete a rule, so to delete a rule, okay, you can do first, you know, view, obviously, view the, so IPTables -L, you know, let's say we're looking at the input chain, so input -N line numbers, right? You know, and then that will allow you to view the table. You'll see the numbers, and then you decide which number, which rule you want to delete. Usually it's going to be the rule that you just added in there. So then you can say IPTables -D for delete in the input chain, and you specify the number, right? So the number that you just got from the list. So that's the, let's say, the index in the list. Okay, and that's probably a very useful command. So add the rule, test it, make sure everything works, then just take it out. And that's it. All right. All right, so let's see where we are. And so we're almost done with IP tables. There's just a couple more things to look at. All right, so we looked at viewing a list. So let me just give you a few more, I guess, commands. Let's just call these like keywords. Actually, let's call it keywords that you might need for the problems. Okay, so I'm just going to give you a list of a few other keywords that might be appropriate. So let's see. All right, so some of the, whenever you do like the command for what the action you're going to take, so -J, so the options could be drop, accept, and reject. Okay, so these are the main ones. Okay, so that's some of the terminology or some of the keywords. Right, other keywords. You could also say, when we say protocol, -P, you can also try all, you know, TCP, ICMP, oops, ICMP, UDP. Okay, so that's another thing that's available. You can specify the interface by saying -I, ENS33. Okay. So these are just some of the additional keywords that you might. Now, when we did ICMP type, we specified, I think it was echo request, but we could also do any. Okay. So that's a possibility. Keep going. Some more keywords. Let's just see a few more. So I think we said, you know, destination port, right? Deep port. Could also be source port. Okay. That's also a possibility. For the IP, you know, for IPs, it's going to be -D or -S. Okay. Now this one is interesting. You also remember, and this also because you did the sniffing and spoofing labs, this should be clear in your mind that, and we saw this also, I believe, in the snort lab. So we have scenarios where we have packets that are in specific states, right? We saw that when we do netstat-na grep TCP. You know, we can see that the packets are in a state such as establish, right, or something like that. So in that case, So whenever you want to look at packets that meet those conditions, then you could use the keywords -m state, and then you specify which states you're going to say, for instance, established. Could also be, something else, right? SYNAC and so on. But, like established, for instance. There's a related one also. Now you could do that. We've done a lot of drops. Let's look at accept actually. So we could do something like IPTables, and then dash insert input in this case. Number 2 dash p TCP, and then we say dash dash destination port 22 dash J accept. Now what's important here is the position of this rule in your chain. So in particular, something like accept needs to be one of the first rules in the chain. Because remember that usually if you put it at the end, by the time it gets to the end of the chain, there's gonna be a lot of denials. And so if you put accept here, it just will never get to it, right? So definitely when you have something like accept, you want to put that at the very top. Right? So it should be there, the very first, if you will. Because remember that the firewalls work by, what is it, implicitly deny, explicitly accept. So you got to accept first, because otherwise everything gets denied. Okay, so this is an example. So also on the exam, I could give you a rule like this one and then ask you to interpret it, right? So what is this one doing? So basically it denies everything, but if you put this first rule, you're saying, well, but anything destined for my computer, the input chain, that is protocol TCP, where the destination port is 22. What is it? 22? SSH. What do you do with it? Accept. Everything else, you drop. Does this make sense, guys? Any questions? All right, so I'm not hearing any questions. All right, so what additional keywords do we have? We talked about states. We talked about the accept. Now, when you use reject, for instance, which we mentioned that you could send a little message, then in this case, we could do IPTables, and then, dash I input. And then we could say dash P all, so all protocols, dash J reject, dash dash reject with, so you send a little message, and so the message would be something like ICMP host prohibited. And this is just so that when you get a reply that says something like this, and you know that it sends out a message, basically. Okay? So that's a little bit more of the keywords. All right, so let's see. Just making sure here. So I believe this is all that you will need to do this homework. Now keep in mind there is a configuration file in every Linux machine that you should not touch, right? So there's a few configurations that are needed for a computer to work, and those you should not really touch. That's why I kind of just recommend just running IPTables from the terminal. Some of you may, you always look up things on the internet, and you may come across some tutorial, and it takes you to the bash file. Maybe something in etc sysconf IPTables. Remember that all configuration files would be in etc. So if you end up somewhere like that, just be aware that there's a few rules in that file that should not be changed. Okay, because they're the ones that allow for the correct operation of your machine. All right, and we're almost done here. What else? Yes, I knew I was forgetting something. Subnet. Okay, so one of the problems talks a little bit about a subnet, right? And so if you want to use a subnet, what would be the generic approach? So again, I'm giving you kind of some hints here. IPTables. Oops. I mean, you still need to show evidence that you remember for all your problems. Show that it works first, then add the rule, then show that the rule did its job, and then take out the rule and show that it works again. All right, so if you wanted to do something like a subnet, you can try IPTables. You probably already know. Another thing is if you do -a input, I don't think I've done examples with this. This adds the rule at the end of the chain. This is not a recommended practice because, as I said, it'll put it, if you have a chain of a whole bunch of entries, it'll put it at the end. If one of these hits before that rule, it'll never get there, right? And so your rule might be correct, but it just never gets there. So probably -i 2 or something, and then you can specify. Let's just do it here. -s, and now you can say 192.168. 1.0, 255, 255, 255.0, right? That's a subnet, and then that's it. -j, drop. Okay. So as you can see, it's pretty easy. I think I've done a lot of things. I don't think I need to do more of these. Should be pretty clear by now. All right. All right, so the only thing that we have yet to cover then is the rule related to port forwarding. I will leave that for later, okay, given that I want you to just get started. So definitely my suggestion is we're going to go to the problems in a second, but let's just, yeah. Okay, so the last thing, next time we meet, we're going to talk about port forwarding, right? So let's go to let me save this file. IPTables. Right. So the last thing is let's just go to the Brightspace environment again and kind of see what we've done, right? So if you remember, We talked about, this is your homework. So you should be seeing Brightspace, the 10 problems. Block ICMP packets going into the router. When it says the router, it just means whatever device it is, the VM. It's fine. So then block ICMP packets going into that device. I mean, it goes into the input chain, right? And I already showed you the rule. Number 2, block SSH requests to that server from the inside network. If you configure from the inside network or otherwise, this would go in the output chain, okay? And basically you just block by SSH and by IP address, okay? Port forwarding, this one leave last because I still haven't talked about it today. Number 4, block HTTP traffic going from A to by IP address. So this is similar to 2, but only by IP address. Number 5, implement a rule that blocks telnet and logs that block to a text file. So that part I haven't done logs, so you got to figure that one out, but you should know how to block telnet, right? So you can do it to the input chain, and it's going to be by port 23. But you got to figure out how to log it, and that's not very difficult. Remember, it's Linux, so Linux has some help for that. Number 6, this one I haven't addressed. You're going to have to run a DDoS attack. You already know how to do that because you have NetWalks or your SCAPI code, right? So run a DDoS attack on the device. And so it's going to be on input, right? Block the device. Remember, you should only do this in your home controlled network. Number 7, drop traffic by MAC address. I think I gave you some ideas about that. You could use input for that one. Number 8, add and test a rule to block access to a specific subnet. We already talked about that one. Obviously, it's got to be the subnet in your network. Number 9, add a rule to block all SSH traffic going through a router. And then devices scheme to bypass the rule. I still need to show you how to do this one, okay? Because bypassing is actually connected to another problem that we're going to talk about later. And then number 10. Let me think about number 10. I'll update this document. And that's it. These are the rules. So we're almost done with IP tables. I just need to cover the port forwarding scenario. So we'll talk a little bit about that one in a future, because that's a more complex problem. So it's good to start fresh with that one. All right, so we will finish that up later on, but at least at this point, you can do 7 out of the 3. 7 out of the 10 rules. Okay, and that's it. That's it for today. This is a good stopping point. I'll stay for a few minutes if you have any questions. So let me click on stop. I'm gonna pause the